Good morning, friends. The next topic for statistics is distribution patterns. Distribution patterns, normal distribution. The normal distribution was first discovered in 1733 by English mathematician D. Moivre. D. Moivre, 1733, English mathematician. Becomes a question for competitive examination. Who discovered the normal distribution? The answer is in 1733, English mathematician D. Moivre. He obtained this continuous distribution as a limiting case of binomial distribution. Normal distribution is also known as Gaussian distribution, named after Carl Friedrich Gauss. Normal distribution is also known as Gaussian distribution, named after Carl Friedrich Gauss, who used these normal curves to describe the theory of accidental errors of measurements involved in calculation of orbits of heavenly bodies. Nowadays, normal probability model is one of the most important probability model in statistical analysis. Normal distribution is continuous probability distribution which is well-shaped, unimodal and symmetrical. Normal curve. The normal distribution of a variable when represented graphically takes the shape of a symmetrical curve known as normal curve, and this curve is asymptotic to x-axis baseline on the either side. Asymptotic, this is the baseline, and either side is this curve is asymptotic to x-axis baseline on the either side. Properties of normal distribution and normal probability curve: mean, median and mode. The normal distribution curve has two parameters with mean and standard deviation. The normal curve is bell-shaped and symmetrical about the line x is equal to mu. It has only one mode occurring, mu I. It is unimodal. The value of mean, median, mode will coincide at the center x is equal to mu, because the distribution is symmetrical and single-paired, where mean is equal to median, median is equal to mode, mode is equal to mu. The normal curve has asymptotic tail progressively nearing the abscissa or the x-axis. Abscissa or x-axis. The range is unilimited, infinite in both directions, but as the distance from the increases, the curve approaches the horizontal axis more and more closely and near touches the horizontal axis x. It has 2 points of inflection, the points where the change in curvature occurs at a distance on either side of mean. The point of inflection of the normal curve are x is equal to mu plus minus sigma. The curve change from concave to convex and vice versa. The quartile of the first Q1 and the third Q3 are equidistant from mu. The Q3 minus mu is equal to mu minus Q1. The quartile division mu3 minus mu1 upon 2 is equal to 0.67458, and Q1 is equal to mu minus 0.6745, and Q3 is equal to mu plus 0.6745. Thus the range of normal distribution from minus 0.6745 to plus 0.6745. The normal distribution is bilaterally symmetrical, so it is free from weakness, and its coefficient of weakness amount to 0. Weakness 0, kurtosis 0. The maximum ordinate y lies at the mean, i.e. x is equal to mu. Its value is y is equal to 1 upon sigma root 2x. When SD increases, the maximum ordinate decreases. Since mean is equal to media is equal to mu, the ordinates at the x is equal to mu, z is equal to 0, divides the whole area into two equal parts. the area right to ordinate and left to the ordinate at x is equal to mu or z is equal to 0 is 0.5. To fix the curve or the mathematical equation is completely determined if the mean mu and standard deviation sigma and variable is completely known. Binomial distribution. This distribution was described by Swiss mathematician James Bernoulli. Swiss mathematician James Bernoulli for binomial distribution, James Bernoulli, 1654 to 1705. Binomial distribution is derived from a process known as Bernoulli's trial. It is discrete probability distribution which is obtained when the probability P of happening of an event is same in all the trials and there are only two events in each trial. Binomial probability distribution is distribution of probability of random occurrence of different combination of case from the two classes of dichotomous variable in a sample drawn from such population. It is a theoretical probability distribution because it can be worked out theoretically using the series of terms of the binomial equation, condition under which binomial distribution is used. The variable should be discrete. The values of x should be 1, 2, 3, 4, 5, etc. But never 1, 5, 1.5, 2.5, etc. A dichotomy exists. The happening of an event has two possible outcomes, either success or failure. The number of trials n should be finite or small. The trial or events must be independent. Happening of one event or trial must not affect the happening of other events. The trial or event must be repeated under the identical condition. Properties of binomial distribution. It is a discrete probability distribution. Binomial distribution has two parameters, P or Q, the probability of success or the failure, and N, the numbers of trials. The parameter N is always integer. The mean, mu, standard deviation sigma, and variance sigma square, and the coefficient of dispersion CD of binomial distribution of the case of class having the proportional P in population are obtained from the sample size N. The proportions P and Q, the cases in the two classes. Mean, mu is equal to NP. Standard deviation sigma is equal to root NPQ. Variance sigma square is equal to NPQ. Coefficient of dispersion CD is equal to NPQ upon NP is equal to Q. CD is equal to NPQ upon NP is equal to Q. Weakness and kurtosis of binomial distribution depends on the proportion of P and Q in the population. Weakness gamma 1 is equal to Q minus P ka whole square upon NPQ. Weakness gamma 1 is equal to Q minus P ka whole square upon NPQ. Kurtosis gamma 2 is equal to 3 plus 1 minus 6 PQ upon NPQ. Kurtosis gamma 2 3 plus 1 minus 6 PQ upon NPQ. Binomial distribution is symmetrical of P is equal to Q is equal to 0.5. It is positively shift when P is less than 0.5 and is negatively shift when P is greater than 0.5. The binomial coefficients are given by Pascal's triangle. Mean, variance, standard deviation, binomial distribution. First, the probability distribution of binomial distribution for R success in any event style is given by PR is equal to NCR Q की power N minus R and P की power R. PR is equal to NCR QNR P की power R. Second, it has mean mu is equal to NP, variance square is equal to NPQ, standard deviation is equal to under root NPQ. N is the number of independent events, P is the probability of success, and Q is the probability of the failure. Poisson distribution. This type of distribution was delivered by a French mathematician Simon Denis Poisson in 1837. Poisson distribution P से Simons Dennis Poisson 1837 Poisson distribution and is called Poisson distribution after the name of his discoverer. It represents the probability distribution of discrete, random variables of rare events whose probability occurrence is very small but the number of events and trial is very large and many approach infinity. It is basically applicable to such events where binomial expression formula can be used in determining theoretical probabilities. It is a discrete probability distribution of rate events and mean and variance is equal. Characteristics. The occurrence of events are independent and random. It is of limited form of binomial distribution. It may be expected in case where the chase of any individual events being success is small. Poisson distribution has single parameter than the mean of distribution. Here mean and variance are equal. Poisson distribution is discrete probability because it is the probability distribution of the whole number 0, 1, 2, 3 and n of events. Poisson distribution is positively swinged and decline with the rise of the value of mean. And Poisson distribution is leptokurtic which decreases with the increase of mean. Poisson distribution positively swinged when declines the rise of value of mean. मीन बढ़ेगा तो पॉजिटिव स्विंग है और मीन घटेगा तो लेप्टोकोर्टिक है. Increase in mean, rise in value of the mean and increase in condition under which Poisson distribution is used. Random variables should be discrete. It is applicable in those cases where number of trials or observation n is very large but the probability of success is very small. A dichotomy exists. The happening of events must be divided into two classes with success or failure, occurrence or non-occurrence. It is independent. Happening of one event does not affect the happening of other event. P should be small close to 0. Poisson distribution is discrete distribution with parameter m. The various constants are mean m is equal to p, standard deviation is equal to under root m, sweetness given by beta 1 is equal to 1 upon m, kurtosis given by beta 2 is 3 plus 1 upon m, variance is equal to m. Example of Poisson distribution. Number of bacterial colonies in a given culture per unit area of microscopic slide. Number of bacterial colonies in a given culture per unit area of microscopic slide. Number of fish deaths in a tank in 1 week due to some pesticide treatment in water. The emission of radioactive particles alpha. The number of mistakes committed by good typist per page. Number of mistakes committed by the good typist per page. These are the examples. I repeat these examples of Poisson distribution with along with the formula. Mean m is equal to p, standard deviation root m, sweetness beta 1 1 upon m, kurtosis beta 2 3 plus 1 upon m, variance m. Number of bacterial colonies given culture per unit area of microscopic slide. Number of fishes death in tank in 1 week due to some pesticide treatment in water, emission of radioactive particles alpha 1, and number of mistakes committed by the good typist per page. These are the examples of the Poisson distribution, and today we have completed the topic distribution pattern, normal distribution, 1730 English, mathematician de Moivre. Binomial distribution, James Bernoulli 6054 705, and Poisson distribution by Simon Dennis Poisson 1837. Important formulas for binomial. Mean is equal to NP, standard deviation sigma is equal to root NPQ, variance sigma square is equal to NPQ, coefficient of dispersion CD is equal to NPQ upon NP is equal to Q, sweetness of binomial distribution P and Q, sweetness gamma 1 is equal to Q minus P whole square upon NPQ, Kurtosis gamma 2 3 plus 1 minus 6 PQ upon NPQ. Symmetrical, P and Q is equal to 0.5, and positively swinged when P is equal to less than 0.5, and negatively swinged P is greater than 0.5. Binomial distribution can be calculated with Pascal triangles. Mean mode median, mean variance standard deviation, NPR is equal to NCR, Qn minus RPR. It has mean mu is equal to NP, variance sigma square NPQ, standard deviation is equal to root NPQ. Number of independent events, P possibility of success, probability of poison में same questions, mean MP, standard deviation root m, sweetness beta 1 upon m, kurtosis beta to 3 plus 1 upon m, variance m. Thank you for watching. Have this video.